He is serving. He is serving from 1996. He is serving as from 2000. His research areas are constant switch mode converters, inverters, multi-level inverters, electromagnetic levitations, active magnetic bearing, soft computing, intelligent control, power electronics, and machine drives. Talking about Sir's work experience, he has 31 years of teaching experience, almost 2 years of research in R&D lab experience, so many number of times as director NIT Durgapur, as well as Dean P&D, Dean Research.
No. Sorry, I am not was director or dean. It is wrongly informed.
Oh,
Somewhere you have taken.
I have taken from internal.
Please just restrict about my
Okay.
academics
Okay.
in short words,
Okay.
and then I will start.
Okay, sir. So, sir is going to deliver his session, today's very important session. Sir is going to tell us on the topic, which is role of power electronic converters in electric hybrid vehicles. Sir, it's my request.
Yeah, thank you, Kamaljeet. Thank you, Kamaljeet, and all the participants here. Before my deliberation, I just want to know about the background of the participants, because I will focus my talk on based on that. Okay?
Yes, sir.
Because there are a lot of things in power electronics and it is related to EV. So I will just concentrate. If there is a background, any background of power electronics particularly,
Yes, sir.
then it will be easier for me to go in depth. Otherwise, I will just go about the EV and their applications in power electronics. Okay.
Yes, sir.
So let me, please tell me that
Yes,
about
sir.
the participants.
Most of the students are from first year, as I can see over here. Few are from second year, third year, and final year.
All are in power electrical engineering?
So first year, they are from multidisciplinary branches.
Okay. And third year, fourth year, they
Third
are
year,
from
fourth year,
electrical?
yes, sir. Second year, third year, and fourth year, they are from electrical.
Okay, then they might have taken at least one course from power electronics.
Yes, sir. Yes, sir.
Guess. Okay,
Yes, sir.
let me share my screen first.
Sure, sir.
Is it coming?
Yes, sir. Yes, sir. It's visible.
Okay. So once again, I thank you to the organizer of this 5 days online short-term course training program on recent trends in sustainable developments, to the Bengal organizer of this electrical engineering department. So Bengal once again, I thank you to the organizer of this and also for inviting me and giving me an opportunity to deliver this topic on this power electronics or electrical vehicle applications. When Kamaljeet talked with me, invited me, that time I thought that to cope up with this 5 days workshop, the theme of the seminar, recent trends in sustainable development, then and which is related to electrical engineering, then I thought it would be the best topic for me to deliver on 2 days workshop. This is power electronics for electrical vehicle applications. So since majority of students are from electrical engineering, so they must know what is power electronics first. Power electronics is that technology which converts electrical power from one form to other form. Okay. So electrical power may be available in the form of AC, in the form of DC, or anything else. So, and what is important is the requirement of the load. That requirement means power level requirement in terms of power, in terms of voltage and current. So we have to convert this as per the suitable of the requirement of the load. That's why power electronics is very important. And here also in EV, electrical vehicle, it is also playing one of the important role, majority role in EV, power electronics. Okay, so let me first go through few slides. What is electrical vehicle? Nowadays, it is everybody knowledge that you must know something basic of electrical vehicle. Electrical vehicle, why it is called electrical vehicle? Because it is a type of vehicle. It uses electrical motor for propulsion instead of IC, conventional IC engine, internal combustion engine. And it operates using electricity stored in rechargeable batteries, which can be charged from external power source such as a grid or renewable energy systems. Okay, then you see there are different types of electrical vehicle. Battery electrical vehicle, that is entirely, as I told you, entirely on electricity stored in rechargeable batteries. Hybrid electrical vehicle, okay. And in EV, this particular BEV, that is, there are no fuel engine, no exhaust system, and produces almost zero emission. That is the advantage, okay. So since they have no fuel engine, so no almost zero emission, and energy is supplied to the motor through battery that must be charged using external power source. And in case of hybrid electrical vehicle, other than your IC engine, electrical motor is also there, but here the battery capacity is very small and it cannot be plugged into the source. So the battery charges automatically through regenerative braking and the engine, helping the improving the fuel efficiency. Okay, and in case of plug-in electrical vehicle, it is also kind of hybrid electrical vehicle. Okay, but the difference is that here also engine and electrical motor is there, but here battery capacity is very high compared to your hybrid electrical vehicle. Here battery capacity may be ranges from 8 kilowatt hour to maybe 20 kilowatt hour. So if we see, all our battery is always there in case of BEV, HEV or PHV. But if we see BEV, their battery capacity, original EV, that is 330 kilowatt to maybe nowadays 120 kilowatt hour. Okay. In a hybrid electrical vehicle, smaller battery capacity, that may be 1 kilowatt hour to 2 kilowatt hour, maybe maximum 3 kilowatt hour. Okay. And here the important thing is plug-in electrical vehicle. Here it can drive for longer distance compared to hybrid electrical vehicle before switching to engine. So you can go with both electrical vehicle mode as well as IC engine mode in case of plug-in electrical vehicle. Okay. And fuel cell electrical vehicle, that is a hydrogen cell. Actually, what is fuel cell? Fuel cell is an electrochemical device that converts a chemical energy to fuels, usually hydrogen that generates electricity, which powers the electrical motor. And it also produces zero emission, releasing only water vapor, and then can be refueled with hydrogen in just few seconds. Okay, so this is that there are present days there are four different categories of EV. Then we see that, just please mute on your some students are actually hello.
Hello. It's my request to all the students as well as faculties to mute yourself. It's my request. Please follow.
So as we see, the sustainable development is your theme of the seminar. So EV, that is a transition toward clean, efficient, and sustainable transportation. In the form of transportation, you know that there are considerable amount of greenhouse emission, around 17% globally. And there are many advantages why we should need EV to reduce air pollution, because petrol and diesel vehicles release harmful gases, mostly carbon dioxide, carbon monoxide, nitric oxide, and so on. But EV produces, as I told, zero emission, improving air quality. Okay. to fight climate change. Nowadays, this is a concern, global warming. So transportation is one of the largest contributors, as I told, in greenhouse gases. So EVs lower this carbon footprint because they use electricity instead of burning fossil fuel. Okay, so when powered, it can be powered by renewable energy sources, solar, wind. So EV then becomes more cleaner to reduce dependence on fossil fuel. Fossil fuels are limited, okay, so and becoming more expensive nowadays. To improve energy efficiency wise, you see electrical system. If you talk about electrical motor efficiency is 80 to 90%, whereas this IC engine having smaller efficiency, maybe maximum 30% to 40%. Okay, so to lower vehicle operating and maintenance cost also compared to other, I am not going to details. To support, as I told you, renewable energy integration, EVs can be charged from solar and wind energy, and the future systems allows EV to send power back to that vehicle to grid technology. There, this concept is very much important to enhance the driving experience. There are also EVs you offer from so that smooth, quiet, and vibration-free driving. Okay, so right now I have owned experience on EV driving. This is from literature itself. Okay, to promote technological development, this is very important. Those who are young engineers nowadays, they can be motivated from this talk that EV will encourage innovation in batteries, power electronics, motors, energy management system. All are in different multidisciplinary field, particularly in the electrical electronics field. So there is a very much opportunities for the new industries and new jobs. To protect the environment, as I already told, that it is very much needed because if we will reduce environmental damage, climate impact, and also reliance on these renewable energy sources. Okay, so it will ensure a cleaner and healthier planet for future populations. Okay, but there are some problems. Okay, every system, every engineering having some advantages as well as equally have some disadvantages. Okay, suppose it will have a limited driving range. Okay, many affordable EVs offer lower driving range compared to petrol and diesel vehicles. Okay, long distance travels, there is a term range anxiety for users. Okay, for long distance travel, still it will cause that range anxiety for users, and it will take a long charging time. Though we can talk about charger in later slide. Okay, that if you even go through fast charger, it may take at least half an hour time to reach 80% of the total charge. Okay, and normal home charging also, it requires at least 6 to 10 hours or more. So charging time, higher initial cost, consider. I am not going in details. Limited charging infrastructure, that is important because everywhere we should need, there are insufficient number of public charging stations, especially in the rural areas. Okay, and you have to standardize this charging conductors, cable contactors. Okay, user may face difficulty finding charger during their long trips. So this is happening particularly in our country. Okay, so limited charging infrastructure, then limited model availability, especially in India, that will take some time to come. Performance issues in extreme condition, considering the battery's performance. Okay, electrical demand and grid. That is also one important research topic for electrical engineering students, those who can work in power system particularly, because lot of EVs means it will have a mass EV adoption may overload the power grids, and you have to upgrade the infrastructure and the cable size, conductor size, transformer size. Okay, so this is once again in the development stage. So there are many, but although this EVs will face some challenges in initial stages, uh, because of this limited range, high initial cost, or adequate charging infrastructure. But these are essential, still essential for sustainable future. Because EV, as I told you, significantly will reduce air pollution and this greenhouse gas emission. Okay, so to combat this climate change, okay, that is a great concern in present days for the considering the global warming. They also have the lower dependence on the fossil fuels, promoting the energy efficiency and supporting the towards renewable energy resources. Okay, so therefore, despite their some drawbacks I have written on this slide, EVs plays a crucial role in achieving cleaner and greener environment and more sustainable transportation, more economical transportation. So these part are very common, and it will be it is common to all students participating in the program. Now I am slowly entering into the electrical system. How does an electrical car work? Here is a diagram. You see the different parts. Different part consists of battery pack, inverter, control module, electrical motor, drivetrain, and the charger port. Okay. So I will come one by one, but let us see how this EV works basically. Okay. So when you accelerate, those who are having driving experience with a normal car, for speed of the vehicle, we should accelerate the pedal. Now here, if we accelerate the pedal, there is a sensor, okay? There is a position sensor, basically, that is a Hall effect sensor that will detect that how much the pedal is pressed, okay? Then based on that signal, that electrical signal, maybe within 0 to 5 volt signal, that will go to the vehicle control unit, and then this vehicle control unit will control the inverter. And finally, this inverter will generate this how much voltage, how much current, how much frequency will required, okay, using different control method. Suppose if you control induction motor using the D/F control, then that inverter will take place, okay, will take care about the vehicle speed. Similarly, when you release the accelerator, inverter will reduce the frequency, because reducing the frequency, then motor speed slows down, and the vehicle will deaccelerate. Okay, so this is the basic thing. I think everybody got understood. Now you just see the structure of the battery electrical vehicle. I will mostly concentrate on that now. Battery electrical vehicle. Okay. Now, if you open up this EV, then you see this is a flow diagram of electronics, power electronics, okay, as well as the different components, battery, motor, and what are the things written there. You see, this is maybe your supply system. It may be single phase, three-phase supply. Then you have to convert it into DC, because your battery needs DC power, okay? So you have to convert either using that single phase rectifier or three-phase rectifier, and it may be uncontrolled using simple diode. Please, I am coming here one by one, or maybe with thyristor with control rectification. And sometimes we have to go through the power factor corrector circuit, because when we just give this converter, when it takes power from this AC, particularly thyristor switch converter, and so that will draw harmonics, and your input supply will be distorted. Okay, we have to do this uh, reduce this harmonics and to make the things voltage this signal sinusoidal, we sometimes need power factor corrector, and that is there in modern EV. Okay, now this DC power goes to this bidirectional converter. Why it is bidirectional? What is bidirectional? I will come in details with the circuit diagram, but for the timing, we just see the power can flow in both directions. The converter which helps to flow the power in both directions, because sometimes when battery needs power, the power will come to charge the battery. Sometimes battery also will deliver power and it may go to the grid, because for grid to vehicle vehicle to grid strategy system, you need that power flows back to the grid. Okay, so in that case, this converter will also be bidirectional. Okay, now you just see here that another bidirectional converter is there, which is actually in case of three-phase inductor motor, it will be when it is exciting the motor, it will be inverter, and when the motor will act as in the generator in regenerative mode, that time it will fed back power to the battery or this grid, this DC bus, by using the converter. That time it will act as a AC to DC converter. That's why these are bidirectional. And there are also, we need for auxiliary supply like fan, light. So these are basically simply DC to DC converter. Okay. So these are the power electronics, it is there. And you can also see better flow diagram from this, and it gives a complete idea in terms of charger system. This is a grid, and this is available in a conventional charging station. Okay, there are, you see what is written onboard charger, level also written level 1, level 2, and this is offboard charger. Okay, and I will come what is onboard and offboard charger. Just you look into this, as I told you, this is AC to DC converter, this is PFC, means power factor corrector circuit. Then DC to DC, this converter may be isolated, maybe non-isolated. Okay, then another DC bus. So from here, DC to AC goes to electrical motor. Now, what should be this converter? That depends on the motor. It may be sometimes DC motor also, where you can see the 4-quadrant DC motor should be, DC converter will be there. In case of AC motor, you know, in case of motor, you know, permanent magnet synchronous motor mostly used. Sometimes BLDC for lower rated motor, lower rated EV, particularly two-wheeler, all these things are run by BLDC motor. So all these, both cases, or in case of induction motor, in all cases, you have to need the inverter. Okay, and there are also different topologies I will discuss later on. Okay, so battery charger plays one important role. So what is battery charger? This is a kind of circuit, basically, converter, basically, to charge the battery, to give the battery voltage as well as current at a particular level. And this level is categorized like level 1, level 2, level 3, fast charger, and nowadays next generation charger, which is required having such voltage, 800 voltage, is rating is more than 400 kilowatt, and within 7.5 minutes or 8 minutes it can charge the battery. Okay, and these are the actually, you know, this is for basically US system. Our Indian system going to standardize, but in level Indian system started from 230 volt, level 1, level 2, and this high power charger and all these things also coming. Okay, so onboard charger already discussed. This converts AC to DC for battery within the vehicle. Okay, onboard charger are located inside the vehicle and it converts AC to DC power. And this power rating is limited to up to maximum 20 kilowatt. And what I am telling is the level 1 and level 2 charging, that is coming under this, the onboard charger are coming under this category of level 1 and level 2. There are certain advantages, as you know. This is convenient, supports from that home AC charging. Even you can charge your vehicle from your ohm. But off-board charger, if you need very fast charger, okay, so that rating is 550 to 500 kilowatt and used for level 3 fast charging. So what is off-board charger? Basically, if you see here, this this conversion, AC to DC conversion is held in the charging station itself. So it gives only the DC power, DC to the EV. Okay, so all these things should be universal. All this connector and all this thing in modern EV. So depending on the requirement, you can connect whether you can connect this one or this connector or this connector. So that all depends. Okay, depending on your charging facility. So, so what I find that from your background, that since you are majority are electrical, first year, so basically you know what is charger. All these charger basically nothing but converter, starting from conversion from AC power to DC power. So you see, this is a single phase full bridge converter rectifier. And when your power requirement is more, in case of fast charger, you need three phase full bridge rectifier. You can also control your output in control manner by using thyristor in case of single phase as well as both in three phase. So depending on our requirement, we should have this. This is mandatory because majority supply is available, power is AC. So at first stage, the first power electronics component, okay, that should be the AC to DC converter. And it is nothing but this single phase full bridge rectifier or three phase full bridge rectifier or control rectifier. Okay, so in some cases, we need linear power converter, particularly for auxiliary power supply. What I have shown here, this auxiliary power supply that is required for your fan, bulb, all these things. Okay, so that needs sometimes linear power converter because of some advantages. All right, because it will produce less EMI and it is a simple circuit. But problem is that in terms of energy efficiency, it is not good because this transistor will work in active region. Okay, so that's why we are going for all this DC-DC converter, because DC-DC converter in power, if you see the power electronics part of EV, the DC-DC converter plays almost 80% of your power electronics. If you see, once again, I am just going to this, here DC-DC converter, here also DC-DC converter, okay, here also DC-DC converter, okay. So you must know what is DC-DC converter first, all right. So DC-DC converter, once again, it may work in this mode, okay, this output, this input is DC, another output, but we are not preferring because of energy efficiency and because of many reasons, larger power handling capability and smaller weight and size, multiple outputs, you need switch mode power converter. So this is the non-isolated converter, simplest form, and this is the isolated converter. Why it is isolated converter? Because you are using high frequency transformer in between. So because of many reasons, here it in one as lecture it is not possible. So there, because of many reasons, we are going for this isolated converters. So before isolated converter, you must know, at least some of you have idea about this buck converter. Buck converter, why it is useful here? Because your supply may be higher than this battery, because batteries, for the charging of battery, we are usually using this buck mode, okay? Because this input side is higher than this, okay? So you have to reduce this voltage by this buck formulation, okay? So I am just explaining only in this case, buck converter, how this converter operates. This is a power electronic switch. So when this switch will be on, okay, that time current will flow through this path and your inductor will be getting charged, and the voltage across this inductor will be this Vd minus Vo, Vd minus Vo, okay, in steady state. So this voltage across inductor, and when the switch is off, this diode is forward bias, so the stored energy will be free wheel through this diode, and this minus Vo will apply across this inductor. So from the volt balance equation, we can find out what is the output input relation. And you see this output input relation is Vo is equal to D into Vd. Now D duty cycle is less than 1, maximum it can go to 1. So your output voltage is only can be reduced from the input voltage. Okay, that's why it is a buck or step down DC-DC converter. Similarly, we have a boost converter. In case of boost and buck boost converter, your inductor with the source side, so that when switch is on, it is storing energy, and when switch is off, it will release energy. And particularly in boost converter, your stored energy will be added with the source energy. That's why the output will be always boosting up the input voltage. Is it correct? If you have any question or any doubt, you may ask me. Why I am going through all this converter? Because these are the structure you must know. At least you get familiar with this structure, because in the charger, battery charger or DC-DC converter for other applications in the EV, these are the configuration. Okay, the power circuit diagram. I am only going through the power circuit diagram because control is something requires more towards the electronics as well as more towards the theory. So it is not possible in one course. So there are many other switching converters like these are all DC-DC converter. Okay, H-bridge converter, half-bridge converter, full-bridge converter. Now I am talking about this converter, this particular full-bridge converter, when your EV is driven by a DC motor, and you should use this converter because it will give all 4 quadrant operation. Why all 4 quadrant operation are required? Because you can rotate your motor, your forward direction, reverse direction, reverse braking, forward braking. So all this 4 quadrant operation can be done with this forward converter. Now this is one topology, single switch based topology, when you use SRM motor. In some applications, SRM motor, switch reluctance motor, also used for case of driving the vehicle train, EV train. So in that case, suppose you need 4 coils, okay, 4 coils for SRM motor. So you just see here all the switches may be connected in the common ground, and there is no need for isolated. And only one driver, only one power supply is required for all the switches. Okay, so this is very efficient and control is easier. So that's why in SRM drive mostly it is replaced by H-bridge, but in some cases where the power requirement is small, then we can use the single switch based power converter. Now isolated switch mode power supply. Why will go for isolation? That output in many cases, in not only EV, in many applications, your output should be isolated from the input for different reasons. Okay, there are many reasons. Okay, so we should use this high frequency transformer for isolation, and this is a topology from forward converter. Forward converter means this is derived from basic buck converter, and similar structure you just see only having this transformer which creates the isolation. Okay, so there are many things. I am not going in details. This is forward. Then if you need that paralleling of converters of this kind of sometimes it is required for more power, means to enhance the power rating, we should connect all the converters in parallel. This is in isolated, this primary side, as I told you, that asymmetrical bridge converter is connected to the primary. the objective is to demagnetize this core of the that primary side of this transformer. Otherwise, transformer will get saturated. Okay, so there are different techniques to avoid this saturation. One is this in case of this time, uh, this is your tertiary winding. So in another case, you have asymmetrical bridge converter. Okay, so to avoid this, we are using this type of circuit. Now, this is half bridge topology. So, half bridge topology also can be used as power charger, this battery charger, up to rated of 500 watt to 2 kilowatt. Okay, and here only problem of this balancing of capacitor voltage that you have to taken care. Now, this is a full bridge circuit. Full bridge circuit means you will just see once again I have gone through this. There are 4 number of switches. 4 number of switches. Definitely you need 4 number of gate driver, but at the same time your power rating is enhanced by twice. You just see compared to a half bridge topology, your power output input gain is double, 2 times of that. Definitely it can go for power application for battery charger or power supply more than 2 kilowatt. Okay. Push-pull converter. This is one interesting topology. Only thing you just see in both primary and secondary having center tap transformer. So you have to take care about voltage balancing in the primary side, because otherwise what will happen that there will be imbalance in the voltage, and that will create the stress across the switch. Okay, and switch might be damaged, and majority of failure of this push-pull topology because of this flux imbalance in the primary side. Okay, so it advantage is that only 2 switches can be used. Okay, so only 2 gate driver, and these 2 switches are driven from the common source configuration. So 1 voltage supply is sufficient for 2 gate driver. Okay, so flyback, all this converter I explained, these are driven from basic buck converter. But in case of flyback, you just see the name flyback. This is actually driven from the basic buck boost converter, so that your output input relationship is related to like D by 1 minus D. Those who have came across basic power electronics, buck boost converter gain is related to this and multiplied with n number of turns. Okay, number of turns is n. So here these are the advantages. So we can go for wide range of variation of voltage, whether it is a buck or boost or buck boost. Okay, we can go for wide range of variation of voltage because it is multiplied with n number of turns. By varying the number of turns, we can have. But normal basic buck boost or buck boost converter, this converter, what I explained first, these are called non-isolated converter because there is no isolation between input and output. Okay, you just see here it is the same ground, where input ground, output ground is same. Now, in case of this non-isolated converter, you can step up or step down. Whether it is a step up or step down, you cannot go beyond 10 times. Okay, but in case of isolated converter, you can go further, maybe 20 times or 30 times. Okay, so that is the advantage of isolated converter. Not only that, you may have multiple outputs. Okay, mostly that polarity also, it can be not only the positive negative, it can also the positive negative, any output, multiple outputs, and different levels can be achieved. Okay, and isolation also having another advantage, because those who are from electrical background, this isolation is very much important. Okay, because of safety, because of protection of converter. Okay, there are some now. So anyway, so these are all about this basic DC-DC converter topology that can be utilized on electrical vehicle. Okay, either, but basic thing you just try to understand. These are all either buck converter or boost converter. Okay, and it is primarily required to understand that when you need buck converter and when you need boost converter, when you need step down the voltage and then buck converter, and when you need the boost up the voltage, buck boost converter. If you need both, then buck boost converter will give the complete solution. Okay, and when you need isolated type converter, when you need non-isolated, definitely isolated type converter means extra cost, extra losses, and so there are again some problems. So you have to taken care of all these things. Okay, but it is preferred isolated mode of converters. This is one circuit diagram that how we can go for closed loop control. So I think if you have it some control idea, then only you can understand. So it is a voltage mode control. You have to sense the output voltage, then compare with reference, and then goes through particular controller, display controller, or you can go for analog control. Then you have to go through these opto isolator. That is important. That is optical isolation. That is required in every power electronics based device, because to protect your low voltage costly control circuit from the high voltage control. This isolation is different. Okay, these isolation I am talking about, that to protect about this, because there may be some short circuit or maybe some other fault occurs in the power circuit. Okay, if there is no isolation, the fault current passes through the ground. So if it is isolated, means there is breaking of this ground, means primary side, secondary, this load control side and high voltage side ground is different. So that cannot be propagated into the low voltage costly control circuit. Okay. So these are okay. If you work on this, then only you can understand. So I can't go something more because I have to cover some more slide. So again, once again, development of some improved DC-DC converter. Why it is required? Because in some cases you need to suppose interleave boost converter, interleave converter. So what is interleaving? You have to understand. Interleaving, see, the converter, two converter are connected in parallel. But they should operate in 180-degree phase shift in case of this two-level interleaving boost converter. Okay. Basically, if you can connect something more, but the phase shift will be different. And phase shift is decided by 360 divided by n. N is the number of connecting converter in parallel. Okay, why we are going for interleaving converter? Interleaving converter, and it is very much used. I will show you some practical circuit for EV. Okay, from the literature. That interleaving converter is used very much because to reduce the ripple current, this may be the ripple current, and if we can operate that both current, inductor current, and this 180 out of phase, ideally it should be cancelled out. So this current is almost ripple free, and the output voltage will also be ripple free. And in case of power handling, because the inductor size will also be less for equal power, and there are many advantages due to presence of several switches. The degree of freedom has been increased because one part of circuit, if it is not working, then other, this fault tolerant capability is there. Okay, converter.
করে দিয়েছে করে
Hello? Hello, sir. Your voice is not audible. Hello? All of you, please stay in this session because sir has left. Maybe some network issues here. Principal sir, most welcome. Good morning, sir. Sir has disconnected. Sir, actually, sir has actually gone to his native place. I was telling कि some network issue may be there. Sir is calling. Just a minute. Hello, all of you, please stay connected because sir is joining back.
Sorry, there was disturbance in network.
Yes, sir. Sir, please continue.
So I just how much time is left actually?
Sir, about 10 minutes.
About 10 minutes. So I just quickly is that sharing is done? I think
Yes,
so.
sir.
So I was in here that converter.
Yes, sir. From
interleaving. This interleaving
this
converter.
part.
Interleaving is used basically, as I told you, for enhance the rating as well as there are many advantages because fault tolerant capability is there, degree of freedom, something more, this more, because you may connect so many things in parallel, okay, and particularly for reducing ripple and enhancing the efficiency, okay. So this is there, it is very much used nowadays, modern EV. I find that there are some applications. Now high gain converter, maybe high gain buck boost converter, high gain boost converter, all these converter, these are actually basically done in my laboratory for my students only. Okay, these are already published and you can see there are different high gain converter topology, transformer less using transformer. We can use different because here you see voltage gain is delta by 1 minus delta square. Why it is required? Just you should have this idea. Sometimes the voltage source, the magnitude is is not so high. Okay, you have to enhance the voltage, but or step down the voltage in square manner, okay, square manner or any multiplication factor. As I told you, the limitation of conventional non-isolated converters, okay, there are some limitation because it cannot go beyond 10 times, either stepping up or stepping down, whether you are going for stepping up for boost converter or stepping down for buck converter, okay. But here this particular converter is connected in series, that's why it is like this, and you may connect so many things in cascade, so you can increase this level, okay, square, then maybe 3 times 4 times like that. But of course there are some difficulties. Similarly, also having input parallel, so source may be connected in parallel and the output can be enhanced by using some capacitor, because you know that if you connect in series of this capacitor, So the voltage here, it may be doubled here and added with this voltage and that voltage. And accordingly, we are getting the 2 times of this. Where this type of converter required, I told you that some cases, suppose if you use the solar system output is low, then you have to enhance the voltage. If you use fuel cell based battery, fuel cell based applications, EV, then also you need this type of high gain converter. Okay, so there are actually different research is going on and already in use. Okay, the different type of converter. This is a picture of electrical vehicle drive system where I am talking about that fuel cell, supercapacitor and battery. Both 3 energy sources are there, and it is also very much used for modern EV. Why it is required? Because you know the limitation of battery. Battery energy density wise high, but power density is not so good, and response time also 10 to 100 millisecond. So conventionally, you just sorry. If you use along with supercapacitor energy density is low, but power density is very high. So for large requirement of power, sometimes, suppose if you need high torque, suddenly for case of power that your drivetrain high torque, then it must be supplied from the supercapacitor. Similarly, fuel cell also having some advantages. Is energy density high, power density of course moderate, but response time compared to this is very high. Okay, so these are all research stage, and some cases I find that already in use. This is called hybridization of different energy sources in electrical vehicle. It is there not only electrical vehicle but also microgrid and other applications. And this is now you can see that after DC-DC converter, because your input is coming from that AC power, that grid, then you are converting AC to DC, then there is a DC-DC converter, this DC-DC converter, and then you must connect to inverter. Okay, because this is inverter, means inverter is a converter, this which converts DC to AC. Okay, because you need AC, and it is written like a permanent magnet synchronous motor. So permanent magnet synchronous motor, if you go through the principle of operation of permanent magnet synchronous motor, in the stator, like induction motor, there is 3-phase winding, stator winding, and permanent magnets are there in the rotor. So when you give the supply, then 3-phase rotating magnetic field will generate, and your rotor will try to block, lock this 3-phase synchronous field. Okay, that's why it will rotate at synchronous field, and that's why it is called permanent magnet synchronous motor. And this is the largest use I find in modern days EV. Okay, still there are some uses of induction motor, SRM motor, and particularly lower applications, BLDC motor. Okay, so bidirectional charger, this is also equally important. But for you, just have an idea. You should have an idea what is this, because I told you that for some applications, because the battery, you just see that you need a bidirectional converter. How it will be useful? Because when it will, how it will be bidirectional, just see, when I switch on the upper switch, then current will flow through these to the battery, and battery will be charged. Okay, now it will have a buck converter. If you see the configuration of buck converter, it completely matches with the buck converter. But when battery, this switch is on, battery will discharge its energy, and the stored energy will go through this diode and feed back to this side. Maybe this is a grid side. Okay, so it is feeding back. So both way power direction is possible, but it is only a 2-quadrant operation, because when it goes to the charging of battery, it only buck mode, and when it discharges, it will be on boost mode. But here, if you see this topology, here it is a 4-quadrant chopper operation is possible, but both direction. That means in both direction, bucking and boosting mode is possible. Okay, so just using this, I am not going. I have to cover this all the means at least some idea about some applications. Okay, so this is once again the isolated bidirectional, what we call more familiar. This is used mostly dual active bridge converter. Why it is dual active bridge? You see two two edge bridge converters are connected and it is isolated. Okay, and when you need that charge the battery, this time it acts as an inverter, and this side converter acts as a converter. And when battery discharges power, then this side will be inverter and this side will be converter. This way it will be bidirectional, and accordingly you can place also off-board and on-board charger in the EV. So this conventional boost converter, as I told you, this drive this motor, and this is already done. Now what I told you in interleaving mode, that you see, these are all practical applications I find in normal EV applications. So there are 4 inductors connected in parallel and working in inverted in interleaving mode. And here this is a topology where this is called soft switching or resonant converter, because if we go for, so far I have discussed about the hard switching converter, that is having higher switching losses. So you have to reduce the switching losses, then you can go for that resonant converter or soft switching converter, either voltage, zero voltage switching or zero current switching. This way you can reduce the losses and you can enhance the overall efficiency of the drivetrain system. Okay, so this is full bridge boost type isolated converter. This once again I have gone through this topology, and it is a complete thing from battery to motor. You just see how it is connected, and these are all that modern practical converter used already in EV. Similarly, isolated half bridge converter. Why it is half bridge? Because 2 capacitor and 2 diode, similar type of converter I have shown you earlier. Okay, so this is the both direction and 4-quadrant mode of operation are possible. Here also used as multi-port converter, because multi-port converter, there is another use, means an important thing, because here you just see both, maybe this is battery and this is supercapacitor, and you can combine this power, and depending on the requirement you can utilize both battery and supercapacitor or fuel cell applications. Now this is already done 2-level inverter. And what is the problem with 2-level inverter? There you see here, and that's why in modern trains you have to go for multi-level inverter. So this is one application here, just showing the diagram with multi-level. Objective is you have to go for number of levels for reducing the TSD and better power quality. Okay, implementation complexity definitely will increase, but you can go for higher level. So these are the advantages of this multi-level, but there are definitely some disadvantages. There are different topologies of multi-level converter we are working, and in our laboratory also my students are working. Okay, there are neutral point clamp inverter and different levels, 5 levels, 7 levels, and these are another topology we have worked on, that active neutral point clamp, T-type neutral point clamp, and that cascaded edge bridge. This full bridge topology can also be connected in cascade and to produce the number of level. In case of multi-level inverter like this will create 5 level. Means these 2 voltage sources can be added to make 2 volt, and similarly we can have -2 volt in between class V0. So it will create a 5-level voltage output where it will be utilized. In case of EV, you see that EV can be fed from different power, means renewable energy sources, and these are all isolated. This may be coming from solar, this may be coming from wind, and you can combine this and then you can feed to the inverter drive system. Okay, so these are 3-phase inverter drive system. As I told you that how motor can be connected here, you can replace this 3 winding of that permanent magnet synchronous motor or 3-phase induction motor or BLDC motor. Okay, then you see the topology of 7-level multi-level inverter. Okay, that is mostly used for higher rating, particularly for heavy duty trucks or Volvo bus. These are useful. Okay, and already in use for this type of topology. So there are different topologies, flying capacitor and all this. It is very much technical and may not be suitable for you. So I am just not going through all these things. Okay. But anyway, I'm just closing here because time is already up and I have also some other assignment. So if you have any question, okay, I will be able to, if possible, then I can able to give the answer.
Hello, sir.
Yes.
Sir, I am Sudhir Chaudhary from Electrical Department. Sir, you have very well discussed about the power electronics part, but from the power system point of view, can I ask you something, sir?
Yes, you please ask.
Yes, as you have huge knowledge, I want to know in the research point of view, what should be the material, next generation material for the EV batteries? It should be supercapacitor or nickel cadmium or lead acid or fuel cell or other things, which are in research now. And what should be the material? Because these all materials have some demerits, sir.
Yes,
So what should be the research point of view? What should be the next generation material we should use in the battery, and what should be the end material for the battery? If the battery lifetime is gone, then what should we use? How we use that battery material, sir? Can you understand, sir?
Presently, I want to work in battery, but lithium-ion batteries are mostly used nowadays.
Yes, sir.
Okay.
Yes,
but nickel, this material-wise research is going on, and I think that will be replacing this lead acid battery or lithium-ion battery. Okay.
Okay, sir. So you are suggesting nickel cadmium, sir?
Yes, nickel cadmium will come forward, and this will replace this immediately.
Sir, can you give me any idea about the end of life material for the battery? What should you do with that?
No, I am not battery expert, but anyway, these are all available in the literature. What should be the material for your battery? Okay. Because battery technology is also growing up, and you know that it is a part of research only. But for our EV, which is available, lithium-ion battery is still we are in use. Okay, but still research is going on, and what I find the nickel cadmium is the maybe the next potential candidate for EV.
Okay. Thank you, sir. Thank you.
Any other question? Any other question from any student? So I guess there is no question. Now I want to conclude the session. Sir, it was really a very valuable session, enriched with vast knowledge and information. So thank you so much, sir.
Now, thank you, Kamaljeet. Only just I want to tell something. Actually, I don't know about the present situation from your department, but anyway, I used to visit earlier Bengal College, and there are some many times I went there. Okay, Professor Ganguly is still there or not? I don't know.
Yes, sir, he is there.
Okay. Now, thing is that for this BTech student, I don't know whether you have a MTech student.
No, sir, MTech is not there.
MTech is not there. Yes. So you can introduce electrical vehicle as a elective course, at least for final year or pre-final year student. Okay.
Sir, we do have as an elective subject.
Okay. And there you specifically give all these things that like battery. This is multidisciplinary. Yes. Okay. But majority focus for electrical engineering students should be from electrical side, motor, what are the different types of motor used, what are the different types of converter used, because 80% of electrical engineering comes from power electronics part.
Yes, sir.
Okay. So as I told you that somebody, Onujda has raised hand. Onshu Singh, Onshu. Do you have any question, Onshu? So I think that EV, electrical vehicle, should be one of the area, and those who that they should go for that project also. Yes. Project means, see, battery charger, just making a converter is not a difficult thing, and it requires few components only. Okay, so they can easily make hardware type prototype like battery charger, all these things, power supply. Those are useful for case of battery, and they can also go for simulation. Okay, the DV complete simulation of battery charger, complete simulation of drive train system that can be used, because more awareness should be there towards EV. Because our aim is that by 2030, at least 30% EV should be there in the on the road. Okay, so that's why at least electrical engineering student, they should know what are the things inside into the EV system, and that's my point actually.
Yes, sir. Thank you so much.
Thank you.
Thank you.
Okay, then I may leave.
Yes, sir. Yes, sir.
Okay, thank you.
Thank you. Thank you. All of you, please stay connected, because very soon we are going to start the valedictory session.